Earth is often called the blue planet, yet most of us only ever see the surface. Beneath the waves lies a world of weightlessness, vibrant silence, and colours you won't find anywhere else. Today, we're breaking down the basics of scuba diving, how it works, the gear you need, and the golden rules of the deep. Scuba is an acronym which stands for self-contained underwater breathing apparatus. Unlike snorkeling, where you're tethered to the surface, scuba allows you to carry your own air supply, letting you stay down for 30 minutes to over an hour, depending on your depth. Contrary to popular belief, the tank isn't filled with pure oxygen. That would actually be toxic at depth. It's usually just filtered, compressed atmospheric air. The same stuff you're breathing right now, just squeezed into a very strong cylinder. To explore this environment, you need a life support system. It includes the Buoyancy Control Device, BCD, which is a vest that enables divers to manage their buoyancy by inflating or deflating an internal bladder with air. The regulator, which takes the high-pressure air from your tank and reduces it to the exact pressure of the surrounding water so you can breathe comfortably. Mask and fins. The mask creates an airspace so your eyes can focus, and fins provide the power to move through the dense water. The dive computer, which is a small device on your wrist that tracks your depth and time, telling you exactly how long you can safely stay down.
What about the physics of diving? You are on a boat with all your equipment and are about to have your first diving experience. The atmospheric pressure of the air that surrounds you is 1 bar, that is 14.5 psi. You inflate your BCD and take a giant stride into the ocean. With the BCD fully inflated, you float at the surface, and once comfortable, the instructor indicates a thumbs down to initiate descent. You deflate your BCD and start descending into the ocean. As you go deep, the pressure increases due to the weight of the water above you. For every 10 meters of descent, the pressure increases by 1 bar. So at 10 meters, the pressure will be 2 bar, and at 20 meters, the pressure is 3 bar. This increase in pressure compresses the air spaces in your body and the gear. You feel your ears closing up, and remember to equalize them by gently blowing against a pinched nose. With the increase in pressure, the density of the air in the tank also increases. Thus, the deeper you go, the more air you consume. You are about to reach the reefs and control your descent by inflating the BCD. The rate of descent reduces, and if you've done it right, you hover perfectly over the reefs. Now, how did that happen?
It is the principle of Archimedes that dictates whether you float, sink, or remain suspended in a perfect state of neutral buoyancy. It states that any object, wholly or partially submerged in a fluid, experiences an upward force equal to the weight of the fluid displaced by it. Neutral buoyancy is achieved by a diver through precise control of the air in the BCD and lungs. Divers also use weights to counteract the natural buoyancy of their bodies and gear. Let's go back to when you are about to control your descent to hover over the reefs. You inflate the BCD to increase the air volume, increasing the buoyancy, which reduces the rate of descent. Let's say you overinflate the BCD. You see that you start leveling off and begin to ascend. Instinctively, you breathe out and reduce the air volume in the lungs, reducing your buoyancy. You start leveling off and achieve the perfect state of neutral buoyancy. Remember, at no point are you holding your breath. It is a continuous process of understanding how the body responds to these changes, react accordingly, and achieve neutral buoyancy. We also know from Boyle's law that the volume of a gas is inversely proportional to its pressure, given a constant temperature. This principle explains why a diver's buoyancy changes with depth. As a diver descends deeper and the pressure increases, the volume of air in their BCD reduces, making the diver sink faster. Conversely, as the diver ascends and pressure decreases, the air expands, increasing buoyancy, leading to a faster ascent. Once your oxygen has reached the red level, your instructor indicates a thumbs up to initiate ascent. Henry's law states that the amount of gas dissolved in a liquid is proportional to its partial pressure. As pressure increases with depth, more nitrogen dissolves into the diver's bloodstream. So at this point, there's more nitrogen in your blood than at the surface. You inflate the BCD and start ascending back to the surface. Let's say you inflate excessively and ascend too quickly to the surface. This results in rapid decrease in pressure, causing nitrogen to come out of solution and form bubbles in the tissues and bloodstream, leading to decompression sickness. To avoid this, divers plan a gradual ascent and do a safety stop at 5 meters for 3 minutes before the final ascent to the surface.